Uh, so here it is. So this we already discussed, weight and summation of activation functions, and sometimes they represent a bias. I mean, the equations. To make a linear equations non-linear, so our bias is a kind of a constant value.
Okay.
So that makes the output non-linear.
Yes.
So in general, see if there is an input and some weight, so we put a method functions, and with the functions we applied on it. If we apply a logistic function, what will be expecting? Two output, right? 0 and 1. Correct? So
yes.
So if there is a one layer only, so the output should be 2. So then you get to know that there is 2 nodes is sufficient to represent it. But what the middle?
Jimmy, sorry to bother you. Did you start the recording?
No, it's starting.
Okay, thanks.
So in general, the simplest would be like putting a bias and then make a what will help you to get into the logistic 2 output. That's why we ultimately the GZ function is like that, which is a logistic regression function where we don't put bias, but in neural networks we put bias. So it's a non-bias, and bias learn more better than the non-bias.
Bias, yes.
And now, so the summation of W1 X1, if it is greater than 0, the neuron fires. So expecting some output. That means the activation function will work. Otherwise, it will not work. And now coming to your questions. So this is in the input layer X1, X2, X3, X4. There are 4 features. So we are, let's say, we expect a binary problem. So then our output should be 2 nodes. Right? So there should be output 2 nodes. But this is what will come in the middle, activation nodes. And this will be decided by the middle layers where we use activation function. So generally, if you see in the middle layer, we don't use sigmoid. We use reluce, reluce or tangent, which makes the feature selections the activation nodes like this. And this is based on this one, W1 X1 plus W2 X2 plus W3 X3 plus W. It's a matrix multiplication of the features and is a weight.
Right.
And this, and on this of these, we apply activation functions. And when you apply activation functions, just try to remember like gradient. So if you apply a linear activation function, that means let's say we apply a linear regression kind of things. So if there is only one dependent variable, let's say you are relying on price of a house based on the square feet. Then what will happen? You're changing y by changing x, right? Dy by dx.
Yes, yes.
What you can say as like a activation function work like this. So change in value with respect to x. So here you have 4 parameters. So and considering weight, whatever you apply the activation function based on that, a new value will give. That is a1, a2, a3.
A3.
So the new value you get in the coordinate, if there is one dependent features, then one value will get dy by dx. There are 2, then 2 will get w1 x1 plus w2 x2. And on that we apply the activation function based on what kind of output you want. Let's say we apply a ReLU or something. So then whatever coordinates we found, so that is the nodes. Here it is activated. The activation nodes.
Okay.
So these are feature selection. They do like this. So, and thing is that we can expect the middle layer, as I said, by divided by 2. I mean, generally we do like this. If there is 1,000 nodes in the input, we do 512 plus 512, and whatever less, we try to adjust in the output node.
Right.
And that also forces one thing, which is called the dropout. One more concept comes into this, so we'll just look at this and see if there is some important things comes here. So here it is showing weight and observations plus a bias has been put, good fitting, and then we get observations this one. So this clearly indicates how it should be made. So because how many will be 1, 2, 3, 4, and so 4 rows will be fine. Activation A1, 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 observations A1, A2, A3. So okay. So just imagine like this is a matrix which created you the number of in terms of 2 things. One is that what we can plot and get a graph, and the same data what we're going to plot is the value which is represented by this matrix.
Right.
So this is a hidden layer, and this is the next output is again decided on. Generally, yeah, here I want to add one thing. The output node, here we are not applying the activation. The activation is only applied on the middle layers.
Okay.
So this is just a representation. Actual output is not applied with activation. And how, if I go to this one slide, here if you say, so from 4 we are getting 3. And so there are, if there are 1,000 nodes is there, and let's say we are 500 is there. 500 nodes, we are expecting 500 middle layers. We are nodes expecting to create a new features. I mean, which inherited the properties from here. But then we do something called dropout, which has been recently discovered by one of the scientists. What is his name? Jeremy or something. Jeremy. What is that concept? Is like he removes some of the nodes from here. Some of the let's say there are many connections is there, and out of 1,000 we want 500. So you drop out some randomly some nodes. Some mathematics you use, but the mathematics are all used for iteration to find out which will be better, which dropout will be better. But ultimate intention is to drop some nodes and to force the algorithm to get the same accuracy, same observations features. To get the same information, but we'll be reducing some nodes from the middle.
So this guy in some other article, he shows the same thing, right? How that when the nodes are getting dropped.
So no, this is written by somebody else.
Okay.
Not that one, the inventor. So he is some professor of Columbia or some university right now.
Okay. Okay.
It's a drawback. Same shape as input. Any shape. So some dropout will be there, and same output. Output should be same as the input. And we drop out here is a classification errors. Nodes which statistics has been shown, and the number of weight updates, and this is the class weight updates with W, and the classification error. Classification error is the last output. If you have three level of classification, percentage accuracy.
Right.
We drop out, the accuracy gone high. That's why the error is getting low. So the dropout mathematics is built to the fundamental is there. And if you want to go, is a high level of mathematics theorem is there. So the basic fundamental is like this: standard neural networks. So these are from input to output connected, and we are removing it. But our intention is to get the same output.
Right.
These are dropping out. So whatever this connection is there is going to be break. But then how can we use these activation functions to bring out the same output?
Okay.
So we are forcing the learning rate. That means we are forcing it to learn with lesser number of nodes.
Nodes, right.
Okay, so when there is a binary classifications, we always use,
Hey Jimmy, it again failed. The installation for Python, it failed again.
okay, so yeah, so you have only, so the best thing I would suggest is, because that's a Windows problem, and there's enough. It's not a skills based, and it's should be, the hints also are less. How to? So it's better to uninstall it. Better to uninstall it going from here. If you go, I think you'll get a add remove program. Uninstall the Anaconda and install it with the same version you have to write, and 3.6 you have to, or 5 you have to convert.
Okay.
And remove forward is there.
Okay. That I will do. That's fine.
Yeah, you can do it. Yeah. So you'll be doing. Yeah. Let me know if it's not doing.
Yeah. Yeah. Around like 3 hours from now, I will just. Yeah, I will do this.
That is the thing that is in Windows. I told you that one is troubling, it will trouble you. Uninstall it because it has no.
No, fine.
Not be issue, but the issue is there in Windows.
Okay.
Might be the support is not good from TensorFlow for Windows. When it's
Okay.
working good in Linux, so should be working good in there also. Right? Once I remember, I could not solve something program, not the installation, and some particular program also. TF-learn is one package. It's difficult. It never always give error.
Right. So like I uninstall it, then I install the Conda with Python 3.5.2.
Yeah, change it and activate environment. Something command is there. Once you install 3.5 and activate environment.
Okay.
So that is to force the from going from Python 3.6 to 3.5 or 7 to 6.
Yes.
So might be like this on the, what was this? Yeah, on the activity. Maybe during the class only you can try one more thing. So
Yeah.
okay, if you try this one, conduct rate minus n.
Okay, I will do this. That's not an issue.
Yeah, is it visible? Should I paste it somewhere?
Yeah, you can send me this article link and I'll just do the steps and see. But first I should uninstall content and install fresh one, right?
Yes, yes. Because
First,
I
yeah,
suspect again
yeah,
because errors can also create some problem.
yeah. So I'll uninstall it and then I'll go through this article and do it then.
So what I'm looking at actually a lot of things are not required. Conduct rate one line may be enough. This one activate
Only this one.
activate my environment. So two
Only
lines
this.
you only required. This one and before that this one, right? This one. Okay.
Okay, so first I create this one and then I activate the environment, right?
Yes, yes. Try this one.
Okay. You can WhatsApp me that. Oh yeah, yeah, WhatsApp is difficult. Yeah, you can
The
send
link
me.
will not go one second.
Yeah, yeah, yeah.
It's getting too slow once again.
Yeah, that's fine.
Yeah, I'll ping you after something. Not coming. So when you have a single two problem, then you go for logistic. I mean, you can get the logistic. What to say? Sigmoid.
Mhm,
Sigmoid as an activation function, but when there's a multi-classification, so we will be using softmax.
mhm, that's okay.
So, and the softmax use, and based on that, the probability of the event occurs. So there is a density 5, there are outputs at their class. And
Mhm,
the probability of all should be 1.
mhm,
The summation of should be 1.
okay.
So this is the probability distribution and the softmax used to work on that. So apple, bear, candy, this one like that. So the thing is that why I put it. So whenever we create the middle layers,
Mhm,
so when we will be multi-classifications, so the last step would be softmax for multi-classification. When there's a
mhm,
binary, we'll be creating 2.
mhm.
So on for different problems, we'll be seeing that.
Yeah. So softmax is what? Softmax is like also like a machine learning some algorithm, or it is like a
Activation function.
it's activation function. Okay,
Yeah,
softmax.
yeah.
Okay.
So there are activation functions required in neural network to produce the and learn the
Mhm,
pattern. So
okay.
ultimately, it's a machine learning only. Let's say the difference is there. we pre we pre-trained we distribute the data in dynamically in nodes.
Yeah, it's okay.
These are connected nodes.
Mhm,
Output, input layer, middle layer, output layer, like that, and it flows through it. And then during the flows, we want to learn it and get the output. And
mhm.
we expect like the what should be the input variable weight according to what should be the output for that particular row.
All right.
Uh, and how what should be the learning pattern by using a graph. That graph name is softmax or logistic. right?
Mhm.
Or any. So, or tangent. And applying that, we get error. Then again, we propagate back into the and trying to we trying to reduce the balance the weight and get the next time good accuracy. So we
Accuracy.
back to again come from again we go into it. So this epoch in one epoch it runs all the records samples of the training.
Trainings, okay.
And so that's how it is different from the other machine learning algorithm. So other machine learning algorithms it put the data on the plan and but it doesn't have a network design predefined. So and it works on the basis of NumPy calculations. Metrics, you can say that all the metrics calculation or maths.
Okay.
Pure mathematics and or ultimately it's pure mathematics going on in the background.
Mm-hmm.
And if you have to understand all the mathematics background, you have to go for masters and PhD on that.
Mm-hmm.
So yes, so I'm thinking even of how it should be benefited going to more details.
Right.
Okay, so let's see a problem actually on how it solves a multi-classification problem.
Mm-hmm.
So there is actually, I show you the data how it looks like and what is the expectation.
Mm-hmm.
So this is a data set of 20 news group. That means there are 20 different news articles are there. Sports,
Mm-hmm.
electronics, hockey, baseball, or political news or something. And
Right.
everywhere there is a file is there, and file contains data.
Mm-hmm.
Atheism. So it's about atheism. Define perfect then I think so some definitions is there something about this religions atheism what is
Mm-hmm.
from a definition of evil ordinary use whatever some news is there.
Right.
So every file has every file has some news and when this kind of news is there then the category is atheism, right?
Right. Right.
And when it is it's called a graphics news it is called computer windows.
Yes.
And,
Right.
under these topics will come it's a hockey news.
Okay. It's okay.
So the things to be learned now is to be trained. So it is said hockey news, correct? So
Yes.
but there should be this file is not good.
There is one title, sport hockey.
Okay, is there a news group is hockey.
Hockey. That's why.
News group is hockey, but this is a very I mean this kind of data is difficult to train. Why
Yeah.
getting high accuracy because of these things?
Yeah.
So,
The hockey is only one word. It's like rest of the things is like.
but the goals, specials is really difficult to actually train this one and based on the data is simply because of the group is there it's getting a little bit easy for you. If you look at the data is not good
Good. Yeah.
because the data has not a pattern somewhere is number 2 number 5 so how will you come to know this is what.
Mm-hmm.
So then if you look at this problem so our idea is to what so this 20 different news as a topic so you have to load it and
Mm-hmm.
we want to load it like this. So whatever you have did earlier.
Right.
So what we are trying to do is every file has a file name.
Mm-hmm.
File name is this one. These are the file names.
Right.
And hockey is the category name.
Yeah.
So category is baseball. whatever 20 is there, this 20 different types will be there in category. And these are file names and these are the news. So what content? So we cannot, everything is not printed out. So I will not rerun it immediately. So otherwise our time will get consumed. So this
Yes.
time, later on I will refresh it. I didn't run it actually from 1 month, I think. So I don't run. So this is not a file 4.5. So there is many are there. Maybe how many are there? Lot of. So around how many will be there? I will tell you. So I'll rerun it at the last. Let's see. Now I don't rerun. So this is file name, category, and news. For that, once you get it, it will be easy for us to divide it.
Right.
So if once I get this, we'll see how we are going to get it. So what is the advantage if I load it like this? So training post is we are interested in two things. We are not interested in the file name. We are interested in these are we are preferring to get the location, and these are to tell you at the last belongs to which category or something I think down. So but our intention is category and the news.
Yes, right.
So if you see train post, so here we are picking in this data news things, right? News is having the data. News is having the raw data, whatever you saw in the file name inside there. Here you will only see the from one line because you see the dot. So it is like a file, but when you load in pandas, it knows that you cannot show you everything. So it is not showing it. But this is we are trying to load everything. We are loading, but it's not showing it. So you got the idea of this file? How? I mean, any doubt on this? How it's loaded, or should I run it from top?
Means means basically like you're trying to load only like the three columns, the file, category, and news. Out of which category and news is important, right?
Yeah, and this is actually total whole records in this one. In any, let's say this file, no, total
Yeah.
whatever content is there inside. So everything is coming for this one rows because this is one file.
So like every data from all the data from that file is included in the news column.
Yes, yes. Yes,
Oh, okay.
only showing only a few words and dotted. That's why I tried to tell you that.
Oh, okay. That's what I was not understanding. Okay,
That's
got
what
it.
I asked you. So it's a total
So,
news, showing few
so,
words.
so all the contents of the file is included in the news column.
Yes,
Okay,
yes.
okay,
For one
got it.
file, this file. Here it is this file. Here it is this file.
This file, yes.
So that means our training data is in this news. We are trying to get out of this 80% data. And 20% or here it is keeping 80% we are keeping, 20% we are keeping for test data.
Right.
And category, we created a category column of there which contains, the category that in the category column, page size means what? 80%. Length of
80%.
data into 80. What is the length of data? So int of length of data into 0.8. So that will give you oh yes. So this is going to give you total number of this one, number of rows. Give me 1 minute. My father is calling me. I don't know why. I'll call him.
Okay, sure. Go ahead.
Hello. Go ahead. Oh, more than others. Confess about the women's. ঠিকে আছে তোমালোকৰ খবৰ ল'ব পাৰা নাই এইফালে কি কৰোঁ এইফালে অৱস্থা বেয়া এইকেইদিন অলপ লাগছে এতিয়া কাম চাম আহিছে এই প্ৰথমে বহুত জটিব লাগে মই পেলাই এটা ছোৱালীক লগাইছোঁ এমপ্লয়টো বেলেগৰ সি কেইদিনমান ইউজ কৰিব দিছে চাফাই চলছে মানে এইটোতো এটা হেৰি কিবা এটা চেটবট বনাব দিছে চাওঁ কালিকে ফোন কৰিব লাহে লাহে আছে কণ্টেক্ট Hello?
Yes, I'm here.
I mean, 1 minute. I mean, 1 minute. Hello, Jawad, what? Yeah, morning. You afternoon. Let me check. I was taking some online class. 1 second, I will hold it. Hello? Yeah. So let's start to put tomorrow. Yeah. So I'll just drop you a message after this class. 15 minutes after that, the class will be over. I will WhatsApp you immediately, okay? And email you also. Yeah, sure. Hello.
Yes,
Hello.
I'm here.
Yeah, sorry for this. Actually, my father has some psychiatric issue, no? He's old, so I cannot tell him I'm in the class or something.
Okay.
Yeah, but try. I mean, this is a long problem, so we'll try to figure out first how to. This is the train size. This is the row. So
Right.
80% of the 80% of the 80% it will be what? Let's say 1,000 records is there. 800 records we wanted to put in the news. And what these things works, that is post. This is there are two things is there once again. This is one is there's one is called first 80% all rows with, and this is the rest 20%. So in the same, I mean, in the that one is pandas data frame, right? You can put it like this to get divide the data into 80 and 20.
Right.
Or 70-30. But before going to this, so this way we have created these our structures. So this is one of the 3 ways. Might be you are thinking why we are taking things like this. So your unstructured data, that day you raises a question, what is unstructured? So now this is a unstructured data.
Okay.
The only thing is we are not question answer training or something, but based on the news we are categorizing it.
Right.
We are making a supervised learning.
Right.
And for that, loading the data is again hard. So there are 2-3 ways. One is like this, you can play with. So the product requirement like this, where your files are putting in a folder, so you can immediately think there is a way like this.
Like this. Okay, got it. Okay. Yeah.
This is the art of, I mean, program, nothing to do with the data science. So first thing is, so
it's a way of loading like this text data into the program.
There are different ways. When it's a JSON, so we'll be playing with JSON file also. Might be you have many data are there in JSON. It's a question answer or something. So then there are some sample programs which tell you how to load it.
Loaded. Okay.
So it should be from like it should be like this one is document, Word document or something. So if it's a Word document or any document PDF, you can do this kind of things. Or if it is like in a JSON or something, you need to do in a JSON reading.
Okay.
So the headers we will be looking at down. So first thing is here I have all this is the main folder where I have the data.
Data, right.
And skds dot load files. Skds dot load files. What we did here it is skds. Here scikit-learn datasets as skds.
SKS.
So SKDS using, I'm loading the files. So first time we are using that.
Right.
So here I am giving only the path and load content false. So I'm just reading it. I mean, we don't want it to display it here.
Right.
So see, this plain file has all the data. What is saying? Data, target. See, as we want, it is giving you loading everything. The file name, the target, and there are 20 categories. So it is showing 9, 4. It is assigning some numbers. Right? 0 to 19 will be the different numbers for 20 categories.
Yes.
So SKDS load files is helping us to load the data, and we see that our data is like this, look like this.
Like this. Okay.
And now we say within files underscore train. So files underscore train, that is a target, and target names. So what is the target is? File name the target is having the target, correct?
Yeah.
And target names contains what?
This one. The atheism graphics.
Target names is the actual our category. Category. So
Right.
target name is our category, and target is index. So 0 to 19. And label files is the file name. File names are label files. So the label files is the category, and label files is the file name. So we put file name, category, news.
That's right.
File name, category, put 3 column name we created. I mean, this is a list. We just wanted to put the header of the data frame. So this is a list we created. This one. And here wanted to populate the data. So now whatever we will be getting inside these 3 things, label names, inside the label names, whatever label files we'll be getting, we wanted to populate in here. Label names under category, and label files, all the news under news, right?
News category.
This is the data frame we wanted to create. That's why we are creating a list of 3 variables.
Right.
So this is the programming part. For f in label files, these files,
Right.
data list is empty first.
Yes.
Dot append.
The label names.
Append f is
this list.
F is the data frame only, this one only, right? So
yeah.
For
F
F
is
label file. So label file is this one. So the file name. So this file name will come here.
Yeah.
From here, right?
Yes.
The file name will come, and then will come label files. Sorry, label names.
Yes.
Here all the category will come.
Yeah.
This one. Label files is this. Label names.
Yeah. Which is the category? Yes.
Label names as a category. And in the category, how to put the category is sorry, label names. This one up to here. So based on the index. So when the I is equal to 0, first one will come, then next one will come, then third one will come, like that. So we are creating, ultimately we are creating this now. For I is equal to 0, first will take the file name, then it will take the category from this one, and then it will take this
Read
part,
the text.
Full text, read text, this part.
This, yes.
So it will get
read text.
Right?
Yeah.
And then columns is equal to data.text. This will be column name. This makes our structure like this. Panda structures. Got right?
Yeah.
A little bit tricky, but you can keep it. That you can know right now that how you can read it from a file.
File, yeah.
And then we are dividing the whole records into 80-20 or 70-30.
Mm-hmm.
And then and then our next job is uh, we know that our level is total target is 20 news group. So we keep the 20, and this is some randomly pick up words. So from vocabulary, how much different words might be.
Right.
So individual words. So this is a something number of words is equal to vocab size. So we are creating a tokenizer. When
Mm-hmm.
this is a method actually we are going to use from Keras method actually
Okay.
in a matrix format. So
Mm-hmm.
because if you see this news, these are all string characters, right?
Right.
Strings. So we have to understand that number of different words are there.
Right.
So we wanted to create a tokenizer matrix. Tokenizer method will give you the size, what you want, the vocabulary size. So that is, we assume that 15,000. So 15,000 is, if you put the size of this, I remember 15,999 something will show as a column or something. Column, I think, row or column, what might be. I will run it. So that's the maximum we are putting the target. Maximum we are putting 15,000 as the target. So create a tokenizer and feed on metrics. So this time much of data, individual words should not be more than 15,000.
Right.
Individual different words.
And what does it contain? Train underscore post?
Train underscore post contains this one, all
Oh
the
yeah.
news.
Okay, got it. The
Content
news.
word. Yeah.
The news.
Mm.
News category. Yes.
So this is the way we are populating our document or text into this tokenizer.
Right.
Feed on text.
Mm-hmm.
So different token has different. Let's say we have a space on matrix, and we want these different many words to be fit on that,
That's right.
and that we do fit on text. Then this have to be do tokenizer dot text to
Text.
matrix. So now this is not converted into binary numbers.
Mm-hmm.
So tokenizer is a token. Different tokens we created for out of 50,000 will be there 15,000. So in that we get to know how many different words are there. All the words,
Mm-hmm.
hockey, football, play, all these words should be there here, individual words. Now these words I wanted to convert into matrix for machine learning purpose.
Mm-hmm.
That is text to matrix. Text to matrix is a method from where is gone? Text to matrix is from Keras actually.
Mm-hmm.
Yes. So
Yeah.
here tokenizer we have imported from Keras.
Mm-hmm.
Keras preprocessing text import tokenizer.
Mm-hmm.
So inside tokenizer text to matrix is there.
Mm-hmm.
So you remember we did TF IDF, right? Convert into matrix, right?
Right.
I by. So this is Keras method.
Right.
Do the same thing.
Mm.
So text to matrix. Here we are, did you see? Remember TF IDF we applied.
Right.
So Keras can do it like this way. The same thing, whatever we did in naive is text classification. And we did it for train post and test post both, but because we have already divided the data.
Mm-hmm.
So this is when you convert, this is the actual matrix. So X10 is like this.
Right.
So X test is I didn't print out. And then the target is also object, right? Strings,
Right.
hockey or something, right? Political.
Mm-hmm.
So then that also need to be converted. So
Okay.
you remember we did hot encoding.
Yes, yes, yes.
Yeah, similarly, another method is called label binarizer.
Mm-hmm.
So label binarizer will also do, there is a 20 categories, 20 numbers it will find out.
So what does the label binarizer does? It converts the, like, for example, news into some binary variable, right?
Yes, it will be converted into binaries.
So 0 or 1, something like that.
Yeah, 0 or 1.
Okay.
Actual printout is I little bit forward. So once I take a class only that I look at the document. And
Mm-hmm.
sometimes it's got 1 month, 2 months. I think the last batch is some physical batch. See, this one is label binary
Mm-hmm.
converted like 1 and 0's combination like this.
Okay.
So it will do, if you look at it, is just forgot to transform, yes, no, yes. No. So for this one, it takes into 1001.
Mm-hmm.
Let's go with that. So I'll get the example and print out. Next class again we'll run it and I'll print out that what is the printing and I scared if I
Okay.
run it, will wasting some 5 minutes then because the data is big now. It's taking time to load.
Load, right, right, right.
The data is very big. So encoder dot feed then so label binarizer we did encoder then encoder dot object dot
Mm-hmm.
feed on the what is it
Print
plain
it.
text. Why plain text? Because this is the data I think target.
Mm.
Plain text is the category. This is the target.
Right.
So as you remember, we used to train the data. So training we only need to convert into
Mm-hmm.
binary.
Binary, yeah.
So train data we put encoded it.
Right.
And encoder dot transform train text and test text we put.
Right.
So so train text has I think where it is above train text is already above. Okay. So the category variable 80% is here and 20% is there.
Mm-hmm.
And why we put a feed on the train text because this is um, we will be using for training purpose.
Yeah. Just a sec, Jimmy. I'll back in a minute. 1 second.
Okay.
Yes, Jimmy. Go ahead. Hey, Jimmy.
Yeah.
Yeah, you can go ahead.
So the thing is, you need to thing is right. The training data,
Mm.
whether I mean the features or the target. That is, we used to train, right? The 70% or 80% data, whatever we have, whatever is means the training data, we wanted to train using feed method. So that is why if you see the encoder, when we created a label encoder or anything, we need to feed again.
Right, right.
But this is something internal and you can control, but we don't require the transform. If you use Python methods, then you need to feed transform.
Right, right.
You don't require transform on it.
Okay.
And so did train and test after that. Sorry, transform after that we did, yes. Immediately we did. I thought of, I just forgot, I thought transform is already taking care of it.
Okay.
But it's internally taking care of it. But now we have to do it. So whenever there is a change in from binary to something, or you are changing the shape, get back to the original things, so we require a transform.
Transform, right, right.
And after that, we use a sequential learning. That is the most common neural network creation. So here we
Okay.
are not using CNN or RNN something.
Sequential means the first mode will learn, then the second layer, then third layers, like that, right?
Second and third, and here internal, the image classification or language processing. I mean, the extra algorithms or extra capability are not putting because
Okay.
it's a classification problem.
Right,
So
right.
here it can be handled like this. So when you are going to train simple text and get the answer or something, then you require RNN. When you wanted to train image, detect image, understand image, then you require CNN training.
Okay.
So
for text, you need a simple neural network.
yeah, no, basic because of we are our expected output is what that is depend on that.
Category, yes.
Yes, that's right.
Okay.
So input shape is vocabulary size. So the notes we used to capture everything, all the different words.
Yeah. One question. This like after you say model add dense 5112, this 5112 indicates what? The number
Middle
of
layer.
nodes?
So the middle layer nodes,
Middle layer nodes. Okay.
activation nodes,
Activation nodes. Okay.
and this is the vocabulary size. It's the row. So it's like this. So our so it is size is like this. So something 14,990 or something. I think this length, total
Right.
number of columns length, number of different words in a column. In a matrix, 1, 2 like this. Number of vertical columns, how many will be there? Means the different words.
That's right.
So that is a vocabulary size. So you always I say like last time you did a 13 features, right? So it's 13 came, right? If you understood, if you remember that one, the last problem. So we have 13 features on that, right? Employee retention or something. Can you hear me?
Yeah, I can.
Okay. So same way, like here it is the size of that is vocabulary size. And this is
Right.
the middle layer, and ReLU is mostly use activation functions can use in the middle layer. And the last layer is softmax because of multiple categories.
Categories. Yes. It is. Now I understand that. Yes.
And this is a dropout is used. Dropout is always used 20 to 30% data.
Okay. So the dropout also decision will be taken by the neural network itself. Like
Yeah,
we don't.
randomly it will drop out. Randomly drop out. For random, that is they have written maths using maths, written some algorithms, difficult algorithms. But
Without compromising on the quality.
pardon?
Without compromising on the quality, right?
Yeah, without compromising the other next layers. What is the
Yeah.
expected output?
Right.
So 30% drop of the neurons, and then again the next layer 512 middle layers
Mm-hmm.
50%, and again redo dropout is 30%, and 500 is how much? And then we are using dense number of levels. Dense number of levels is the last one. Last one
Right.
is 20 we want. So this is a 20 value. This is coded above is a 20. And use softmax. So this is the summary is our loading the model. So So from here we'll see in the next class. So you can take this and run it. Totally when you run, and also what you can do is you can print those things wherever you have doubt. And when you take the size of the trained post, you'll get to know why we use this much.
Right.
When you print out this one, this data, trained post size, you have to put the size of this. Or you can directly get the size of this data size. Oh, sorry, the data size will not help because we are converting into matrix here, right?
Right.
So here, so you require get into that one. Tokenizer, you can get the size here. X train and X this. How many? So size of the matrix you can see.
Okay.
So just play around this problem in the next class. So we spend time on it.
Yeah. I will try to fix up the Conda thing, and
correct. In the meantime, you ping me. So
yeah, and then I will just play with this one and the last course material, and then like if I have any questions, I'll shoot you something by today evening itself, so that we have enough time to cover all the doubts before the next class.
Yes, sure.
Okay.
Okay. See you.
Okay, thank you.
Okay, bye.